So we are starting with the 20th lecture of algebra, and this time the focus is on functions. We will go over the basics, the composite functions, and inverse function, everything in this particular class. Now, first of all, what is the idea? What is a function? Now, function, the word suggests that there is some kind of work involved. So what we do in a function, it's a rule that turns one number into another number. The one number that we plug in, that's called the input. And the number that we obtain, that is called the output. For example, if we have a function fx is equals to x plus 3. Now the function is denoted by either the symbol fx or gx or hx, any alphabet, and inside a bracket, there is x written over here. This x is the input. So fx is equals to x plus 3. What this means is that you take in any value of x and then you add a 3 to it. So the function of this function is, that means the work of this function is add 3. So therefore, if I plug in this value, which is 0, so therefore 0 plus 3, it will be turned to 3. If I write if x is equals to x plus 3, I'm using the same function, and let me plug in 4. So 4 plus 3, that comes out to be 7. That means if I just draw a square over here, a circle over here, and then a circle over here, and then let me write the input, let me write the output, that means x becomes x plus 3. That is the function. That means 0 becomes 3 and 4 becomes 7. So this is the input, this is the output. Later on in higher math, we will refer to the input as the domain and the output as the range. But currently, we are just limiting ourselves to the values, to the names, input and output. Function can also be written like this arrow. So this arrow that's drawn over here like this. So people also use this terminology. The examiner might use this terminology to write it like this. So now let's move on. Let's look at this first example. So this first example says for the function fx is equals to 30 minus 2x squared. What it means is that plug in the value of x, square it, multiply by 2, and then have it subtracted from 30. That's the meaning of this function. So now if I want to evaluate f of 4, I'll plug in 4, 30 minus 2 into 4 square. 4 square is 16. 16 into 2 is 32. 30 minus 32 is negative 2. A pretty simple basic example. It's one of the easiest chapters. Let me plug in f of negative 2. If I plug in f of negative 2, 30 minus 2 into negative 2 square, that is 30 minus 8, which comes out to be 22. Now, these are some of the exercise. Let me just pick one of them. Yeah, let me explain this a little bit further. For example, fx is x minus 4. It subtracts 4 over here. Over here, fx is 4x. It multiplies by 4. What is this function doing? It's multiplying by 3 and adding a 4. So let me focus on this one. That is part C, question number 1. Part C, fx is equals to 3x plus 4. Now, if I want to work this out, let me plug in 0. If I plug in 0, that is 3 into 0 plus 4, which comes out to be 4. Now, it could be a reverse kind of question also, given that f of x is equals to 4, or instead of x, they can write another constant, another symbol of a, given that f of a is 4. This is C part 1. This is C part 2. Find a. So what will we do? We will write f of a is 3a plus 4. F of a equals to 4. In other words, 3a plus 4 equals to 4. 3a equals to 0. In other words, a is the 0. That means if the input is 0, then the output is 4. And that is exactly what we have done over here. Pretty basic. Let's look at these questions. Now it's about squaring. So for example, over here, the first one, gx is equals to x square. This is a square function. Gx fx is equals to x square minus 4x. Take the input, multiply it by 4. Take the input, square it. The square thing minus 4 times this value. Let me work it out. 2 part A, actually part B. So this is 2 part B, fx is equals to x square minus 4x. Let me plug in part 1, which is 7. So f of 7, that is 7 square minus 4 into 7. 7 square is 49. 4 into 7 is 28. This answer comes out to be 21. Something like part E. Now it says f of t is equals to 4t minus 3 whole square. Now let me take back you to quadratics. This is in the completed square form almost. This is not exactly, but something similar to that. So this is also quadratics because it has x square. This is also quadratic. So f of t is 4t minus this thing, minus 3 square. Let me plug in 0.75. So therefore, if I evaluate f of 3/4, that is 4 into 3/4 minus 3 whole square. 4 cancels out. 3 minus 3 whole square, which is 0 square, which comes out to be 0. It's a pretty basic question. Something of the sort. So now let me explain this one. This is like a reciprocal function. Remember, we have done reciprocal. So this is reciprocal function. This is the same type that we discussed maybe in the last class or the class before that. Y is equals to k over x. So k is a positive constant and the graph is formed something like this and something like this. This is that reciprocal function. So now if I plug in 3a, gx is equals to 20 over x. Let me plug in a value, let's say 10. So g of 10 is equals to 20 over 10, which comes out to be 2. Pretty basic. This one is a radical function. It has a square root over here. So this is a radical function and we take the positive square root. For example, part B, gx is 2x minus 1. Gx is 2x minus 1 and let me plug in 5. So, and the square root is also there. So g of 5, that is 2 into 5 minus 1 square root. That is 10 minus 1 square root, which is square root of 9, which is 3. This one is a power function, the exponential function. Remember, y is equals to a raised to power of x. A is positive, and the graph goes like this, just giving you all these little snippets. So therefore, g, this is fx is 8 power x minus 9. It has been translated 1 unit down. Let me evaluate this. Part 2, f of 1/3. F of 1/3, that is 8 raised to power of 1/3 minus 1. Square root of 4 is plus minus 2. Square root, cube root of 8 is also 2. So raising to a power of 1/3 is cube root. This is 2 minus 1, which comes out to be 1. We have not done indices as of yet. That's on the agenda, definitely. Root a, and if I write m over here, that is a raised to power of 1 over m. If I write square root, in square root, we normally don't write the 2. That is a raised to power of half. A 1/3, that is a raised to power of 1/3. So that is what has happened in this particular question. I hope this is all good, all clear. Let me also solve this one. That is f of t is 2 raised to power of minus t plus 5t. F of t is 2 raised to power of negative t plus 5t. Which part is this? This is h. Let me plug in a value. Let me write this thing, f of 3. So part 3, f of 3. That is 2 raised to power of minus 3, 5 times 3. 2 raised to power of minus 3 is 1 over 2 cube plus 15. This is 1 over 8 plus 15, which can be written as 15, 1 over 8. Now, all these exercise are from this book, which I have already sent it to you. And let me just show you the cover page so that you remember exactly which book am I referring these questions from. This is the one. Very nice book for basic exercise. So you already have it. I have pasted the exercise from there. So now let's move on. Something like this, which is the input value is in terms of some constant. For example, f of x is 30 minus 2x squared. F of x is 30 minus 2x squared. We have to evaluate f of 2t. So wherever there is x, you have to plug in this value. So this is 30 minus 2 into something square. What goes over here? 2t. Just go step by step. That is 30 minus 2 into 4t square. That is 30 minus 8t square. That is the answer. Expressions like this. For example, let's look at part C. Part C, f of x is 4x minus 1 over x plus 4. It's in a fractional form. Let me evaluate f of t. So f of t, that is 4t minus 1 over t plus 4. Something like part D. F of x is equals to, let me just write it properly. Part D, f of x equals to square root 5x minus 1. Let me plug in 3x. F of 3x, that is 5 into 3x minus 1 square root. That is 15x minus 1 square root. Just leave it as it is. It's an expression. These are the answers. I think this is the one that we did. This is the one that we did just now. Now let's talk about function of a function, which is known as composite functions. So composite function, it's also known as function of a function. Now let me illustrate this with a simple idea first. Let me take a function fx, that is x plus 1. Let me take a function gx, which is square, x square. What is the function of this function? Add 1. What is the function of gx? That is square x. Add 1 to x, to the input value. Square the input value. Now, let me take a value. Let me find an expression first. Let me find f of gx. Just the way you found these particular expressions. Agreed? Just plug in the value of the symbol. Wherever there is x, just plug in the input value. So f of gx, in other words, gx is the input, that is gx plus 1. Now, gx is this x square. So therefore, this is x square plus 1. Similarly, I can find g of fx. What it means is that inside gx, wherever there is x, just plug in fx. So therefore, this is fx, the whole thing square. Now, what is fx? Fx is x plus 1. This is x plus 1 whole square. Now, what is the difference between the two? Over here, first square, then add 1. So over here, first square x and then add 1. Over here, first add 1 and then square the result. First square x and then add 1 to the result. Now, let's do one thing. I have fx x plus 1. Let me write over here fx is x plus 1. Let me plug in a value of 5. So that is 5 plus 1, which comes out to be 6. Now let me take this value and plug in gx. Gx is x squared, therefore 6 squared, which is 36. Now let me take these two things, f of gx and g of fx. F of gx, x squared plus 1. G of fx, x plus 1 whole square. Let me plug in this value over here. Let me plug in this value over here. I want to see which one will give me 36. So if I write 5 over here, that is 5 square plus 1, which is 26. If I write over here, 5 plus 1 is 6, 6 square is 36. That means gfx is the same thing as first f and then g. So sometimes they can ask the sequence also. That means first f, then g. It will have the same result as g of fx, which makes perfect sense. Because when I insert x, it will first go through the process of f, and then the result of f will be plugged in g. So that is exactly what I've done. I have plugged in 5 in fx. I got 6. I'm plugging that result in gx. I'm getting 36. Therefore, this new machine, this new function, the function machine is what? First f, then g is g of fx. So remember it like this. We write it in English from left to right. And we read it in Urdu or Arabic. That is from left to right. Right to left. This is right to left because x goes in first in place of f and the result goes in g. First f, then g, that is g of fx. So sometimes they can ask this tricky kind of question also. Now let's look at this and let's read this thing first. If fx and gx are two functions, then g of fx is a composite function. It could be gfx, it could be f of gx also. Gfx means put x into a function f and then put the answer into function g. Gfx. Is that what we have done? Yes. Gfx means put x into f. That is what we did. We put x into f. This is the result. The result goes in g. Gfx is also sometimes written as g bracket fx. It means the same thing. Another example of the same type. We have fx is 3x minus 2. Gx is x squared plus 1. Calculate the value of f of 3 and then use it as an input in g to find g of f of 3. So we plugged in 3 over here. 3 into 3 is 9. 9 minus 2 is 7. And then plug in that value in what? In gx. So that is 7 squared plus 1, which is 50. Now we need the expression. So this is evaluation. And this is expression, which we already did. Find f of gx. So this gx, that is x squared plus 1, that goes in place of x. So 3 into x squared plus 1 minus 2, and then simplify. What you get is this thing. So now let me pause the recording over here, and I want you to try out question number 1, both the parts. So now the questions that I've shaded, let me solve this. It's one question with 4 parts. Question number 1, fx, x plus 3, gx, x minus 1. First part A, evaluate g of 4. So this is gx, that is 4 minus 1, which comes out to be 3. Part B, use your answer to A to find f of g of 4. F of g of 4, basically, g of 4 is 3. So just plug in 3 in fx. So therefore, this is f of 3. That is 3 plus 3, which comes out to be 6. Basic question. So just let me remove this thing. And then the second thing, this is part A, part B done. Part C, f of 5. So f of 5, that is fx is x plus 3, that is 5 plus 3, which comes out to be 8. And then part D, use your answer to C to find g of f of 5. So g of f of 5, that means this thing is f of 5. So just replace, that is g of 8. What is gx? X minus 1. That is x minus 1, which is 8 minus 1, which is 7. Let me add something more to it. That is finding the composite function. Let me find f of g of x. Let me find g of f of x. So first of all, f of g of x, that means gx should go in fx. So gx should go in fx, so that is gx plus 3. This is gx plus 3, which is x minus 1 plus 3, which is x plus 2. And similarly, g of fx, that means fx inside g. Fx is x plus 3, gx is x minus 1. So this is fx minus 1, that is x plus 3. Yeah, it's x plus 3 minus 1, which comes out to be x plus 2. So it's a beautiful coincidence that f of gx and g of fx is exactly the same. There are more questions like this. And then let me try out something from here. 4, part A. Fx is 10 minus x. Let me just check the sound. The sound is on. So fx is 10 minus x. Gx is x squared. And let me first find the expression and then evaluate it. So first find g of f of x. So g of f of x, it means take this fx and plug it in inside gx. So gx is x squared. So this thing would be squared. What goes inside? That is fx. What is fx? 10 minus x. No need to expand it. Now let me evaluate g of f of 8. So g of f of 8 is 10 minus 8, the whole thing square, which is 2 square, which comes out to be 4. Basic question. Let's double check. This is 4 part A, 4 part A, part 1, 4 part A, part 1. That's right over here. Now let's talk about the inverse function. So inverse of a function, that is inverse function. So what does an inverse function, what is the performance of inverse function? So now it says an inverse function reverses the effect of a function. That is the main thing. The inverse of fx is written as f raised to power of minus 1x. That's how it's written. Now let's say, without anything, the inverse or the reverse of add is subtract. For subtraction, it's addition. That is obvious. For multiplication, the reverse process is division. If I say, let's go ahead and square something, so the opposite, the reverse process is square root. Similarly, if I say cube something, then I'll say cube root. If I do a combination, first add 2 and then multiply by 3. Now, the first process is add a 2. The second process, then multiply by 3. So what should be the opposite? Now, this is kind of tricky to understand. Let me first give you an even more simpler example. Let's say I want you to go straight 2 units and then go 3 units to the right. So 2 units north, 2 blocks or 2 units north, and then this is the east, then 3 units east. Now let's say there is no other route that you can come back. What should be the opposite? The opposite should be 3 units west and then 2 units south. Now remember the order. First it's north, then it's east, but in the reverse process, first the opposite of east, the most recent one, that is east, that becomes west, and north is turned to south. That means multiplication will turn to division. Addition will turn to subtraction. That means first go in this direction, division by 3, and then subtraction of 2. That is what we are going to do. Now, let me just solve it algebraically. If I say fx is 2x plus 3, does it translate this thing to words? First add 2, then multiply by 3. First add 2. No, I think I wrote in the wrong order, my bad. First add 2, and then the result is multiplied by 3. That is what we have done. So now what is the reverse? The reverse is first divide by 3. First, let me write this thing as gx. First divide by 3 and then subtract 2. Let's see if this is even right. Let me plug in a value 1. That is 3 into 1 plus 2. That's 3 into 3, which is 9. Let me plug this thing 9 over here. And if it gives me 1, that means my process is correct. So therefore, this is 9 over 3 minus 2, which is 3 minus 2, which gives me 1. Yes, I got it correct. That means, of course, I'll tell you a mathematical way of doing it. But first, let's focus on the original function and the inverse. First add 2, then multiply by 3. The reverse is first divide by 3 and then subtraction of 2. Addition and subtraction are opposite. Multiplication and division are opposite. Square, square root, they are opposite. Opposite as of reversing the process. Cube and cube root, opposite, reversing the process. So that's how we work out inverse function. So now let's get started in generalizing and getting a formula for the inverse. So let me add a page and let me write a simple thing. Fx is 2x. So if inverse should be x over 2. This is doubling, it's half. Half is the inverse, reverse process. Now let me plug in a value 4. So 2 into 4, this comes out to be 8. And in the inverse, if I plug in 8, I should get back 4. So that is 8 divided by 2, that comes out to be 4. It's pretty basic idea. If I plug in 4, I get 8. If I plug in 8, I recover back 4. So now, instead of 4, let me write, let y is equals to fx. Therefore, this one is the input. This one is the output. That means in the inverse, what should be true? In the inverse, if I plug in y, I should recover back the x. If I plug in y, I should recover back the x. So now Can I use this to find this expression even though it's very basic? Of course I can. Let y is equals to fx. F inverse y is equals to x. Remember, fx is equals to 2x. So you will write y is equals to 2x. You will replace this fx with y. So y is equals to 2x, make x the subject, y over 2 is equals to x. But what is x equals to? X equals to f inverse y. So the expression is done. It's just that it's written in terms of y. Let's write it in terms of x. So therefore, f inverse x is x over 2. That's how it's to be done. Let's look at this example. Now, in this example, they have done it conceptually. Multiplication by 7, add a 1, divide by 2, you get this thing. Now, division by 2 is multiplication by 2. Addition of 1 is subtraction of 1. The result is now divided by 7. Now, can I get the same result using the formula? The answer is definitely yes. Let y is equals to gx. It's not fx, it's gx now. Therefore, g inverse y equals to x. So therefore, what will we do? We will write it like this. Y is equals to 7x plus 1 over 2. 7x plus 1 over 2. First of all, 2y is 7x plus 1. Next step, 2y minus 1 is 7x. The very next step, 2y minus 1 over 7 is equals to x. Now, what is this x equals to? G inverse y. But x is equals to g inverse y. So therefore, g inverse y is equals to 2y minus 1 over 7, or we have a habit of writing in terms of x. So g inverse x is 2x minus 1 over 7. That's how the inverse function is evaluated. All good, all clear? Now over here, they're asking for the inverse of each. This is pretty basic. X plus 4, the inverse will be x minus 4. X minus 3, the inverse will be x plus 3. X minus 7, the inverse will be x plus 7. 2x, we just did this. That should be x over 2. X over 3, it should be 3x. X over 6, it should be 6x. 4x plus 3. So 4x plus 3, it should be what? Let's write it out. 2a. Let y is equals to fx. Therefore, f inverse y is equals to x. So therefore, y is equals to 4x plus 3. Y minus 3 divided by 4 is equals to x, but x is f inverse y. So therefore, f inverse x is equals to x minus 3 over 4. You can first write this thing as f inverse y is y minus 3 over 4. It's just changing the variable back to x. That is all what we have done so far. Let's move on. Another question like this. Find the inverse of this function. Fx is equals to 4x minus 1 square root divided by 3. So that is exactly what I've done. Let me just do my own working. Let y is equals to fx. Therefore, f inverse y is equals to x. So therefore, y is equals to square root. Y is equals to square root 4x minus 1 over 3. 3y is 4x minus 1 square root. 3y, the whole thing square is 4x minus 1. 3y, the whole thing square is 9y square plus 1 divided by 4 is equals to x. But what is x? X is f inverse y. So therefore, f inverse y is 9y square plus 1 over 4, or just change the variable. F inverse x is 9x square plus 1 divided by 4. So let's double check. That is 9x square plus 1 divided by 4. Questions are of this type. The answers over here. Something like a more elaborate question. So I'll be taking another 15 minutes or so. so that I can complete this topic thoroughly with some good examples, more good examples. These were good, even better, some word problem type. Now the question says, if x is equals to 4x minus 7, as you can see on the screen, and gx is equals to 1 over 3x plus 2. Now it says, solve the equation f of gx is equals to 1. A good question. So now what we do is that fx is 4x minus 7. Gx is this fraction, 1 over 3x plus 2. First, find an expression for f of gx. That means gx will go in f. This whole gx will go in f in place of x. So therefore, this is 4gx minus 7. That is 4 into this bracket minus 7. What is this bracket? This bracket is 1 over 3x plus 2. No need to simplify. Just equate it to 1. So just equate it to 1. So therefore, 4 bracket 1 over 3x plus 2 minus 7 is equals to 1, therefore equals to 8. This negative 7 goes on the other side, adds up. 1 over 3x plus 2 is equals to 8 over 4, which is 2. So therefore, 3x plus 2 is equals to 1 over 2. This simplifies to 2. Cross multiply. This goes down. This goes up. 3x plus 2 is half. 3x is equals to half minus 2, which is negative 3 over 2. That is 3x. Therefore, x comes out to be negative half. If I'm not mistaken, that should be the answer. X comes out to be negative half. They have done, the author of the book has done by using a lot of big numbers. I have done it with small numbers. That is the way that I work. Simplify as much as possible. Now, this exercise, this is like a miscellaneous exercise. Let me do some questions from here. Miscellaneous exercise. So let me work out this question. I have pasted it separately. This one. An object is dropped off from the top of a tower. The distance s meters, the object has traveled t seconds after being released as given by this formula. So first of all, an object is dropped from the top of a tower. It's coming down. That's the object. That's the top of the tower. It's coming down like this. The distance s meters, the object has traveled t seconds after being released is given by this formula. S is equals to ft. Ft is 5t squared. In other words, let me write this thing. This is S. Not make sense. S is equals to 5t squared. First part, calculate f of 4. That means the plug-in value is the time. So that means what is the distance when 4 seconds have passed? 4 into 5 into 4 square. That's 5 into 16. That comes out to be 80 and it meters. The units are meters. That means after 4 seconds, the distance traveled by the object is 80 meters. That's what it's doing. Solve the equation f of t is equals to 12.8. Part B. F of t is equals to 12.8. Let me grab my calculator. And yes, right over here. So first of all, f of t is 5t square is 12.8. So first thing, 12.8 divided by 5 is 2.56. T square is 2.56. And if I'm not mistaken, t comes out to be 1.6. Of course, you can use your calculator. I have used my memory. So t comes out to be 1.6 seconds. Yes, it is correct. Now, what does it mean in words? It means that what is the value of time when the distance covered is 12.8 meters. That is what they're asking. That means either they can give us the time ask for the distance, or they can give us the distance, ask for the time. So f of t is basically distance. So basically they are saying solve the equation S is equals to 12.8 for this part. All good, all clear? Let's do one other question. The function f of t is equals to 9 over 5t plus 32 can be used to convert a temperature from degree Celsius to degree Fahrenheit. Okay. So this t is Celsius. And this f of t is Fahrenheit. Okay, Fahrenheit. Okay, whatever. Take it. Long name. Part A, f of 20. F of 20, just plug in 20. That is 9 over 5 into 20 plus 32. 5 ones are 5 fours are 4 nines are 36. 36 plus 32, that is 68. Part B, solve the equation f of t is 60.8. F of t is 60.8. So basically find t. 9 over 5t plus 32 is 60.8. Let me grab my calculator. So t is 60.8 minus 32. 5 goes up, 9 goes down. So that will be easier for me to simplify. So that is 60.8 minus 32. That is 28.8 divided by 9. 3.2 into 5, that is 16. So t comes out to be 16. So again, the concept is the same. They can give you t, ask for f of t, they can give you f of t, and then you can ask for t. Work out f inverse of t. That's another nice question. Part C, f inverse. Let y is equals to f of t. First, we used to write f of x. Now it's in terms of t. What's the big deal? F inverse of y, f inverse of t is equals to y. I'm just mixing up the things. Hold for a second. Y is equals to fx. So f inverse of x is equals to y. That's how this thing is done. Y. So f inverse of y equals to t. So now remember the dots that I used, input, and this one is output. And you plug in the output, you will recover back the input. So that is what we are doing. So let's work it out. Let me use a black marker. So y is equals to 9 over 5t plus 32. Y minus 32 is 9 over 5t. Therefore, 5 over 9 bracket y minus 32 is equals to t. But what is t? F inverse y. So this is the same thing as f inverse of y. But we are writing in terms of t. F inverse of t is equals to 5 over 9. And this is t minus 32. That is the expression for the inverse. Part C is also done. Explain what your answers to part A to C represents. Good question. Part A, what does it represent? It represents temperature from degree Celsius to degree Fahrenheit. So 20 degrees Celsius is giving me 68 degree Fahrenheit. In part B, it's the opposite. This is Fahrenheit given. I'm asking for degree Celsius. So part A is Celsius to Fahrenheit. Part B, Fahrenheit to Celsius. Our last part, that is the expression, the inverse, that will convert Fahrenheit into Celsius. The original expression is Celsius to Fahrenheit. This one is Fahrenheit to Celsius. Let's double check the answer for 13. 13, the first part, let's double check. That is 68. This is 16. This is 5 over 9 t minus 32. 20 degrees Celsius is equivalent to 68 Fahrenheit. 60.8 Fahrenheit is equivalent to 16 degrees Celsius. The inverse function converts temperatures from degree Fahrenheit to degree Celsius. So that completes Algebra lecture 20. That completes the whole concept of functions in and out. That is the basic, inverse, composite. Everything is done and dusted. See you in the next class.